Okay, I welcome you all again to today's session. So till the last module, that is till the third module, we have studied the different aspects or different concepts as such. In the first module, we just studied about the architectures, machine architectures like SIC and SIC-XC. In the second module, we came across this assembler. You studied about the assembler in the second module. As such, either it can be SIC architecture or it can be SIC-XC architecture. How does your assembler works such that how it will take the source program as the input and how it will produce the object code as the output. That is what we had studied in the second module. In the third module, we came across with the linker and the loader and linking operations. That's what we studied in the third module. How it will take the object code, and if there is a necessity of linking, how it will be taken care by the linker. That is what we call as program linker. Then how it will be loaded to the main memory by the loader. At the time of loader, it can be a normal absolute loader or it can be relocatable loader or linking loader. So all that we have studied in the previous concepts. That's what till the third module. So today we will be taking up the next concept, which is on the macro process. This macro process, remember, I can say that this macro processor is a part of the assembler. And why does this macro processor is required? There may be the possibility of where you can make use of the macros in your source code. Understand? There may be the possibility of macros in your source code. Further, in the further slides, I'll show you what are those macros and how to use those macros. What is the necessity of macros? All that I'll be explaining in the further slides. But as of now, just as an introductory part right here, if suppose in your source code, if any programmer have used the macros in the sense, then before the as any assembler, because here itself I said what assembler will take the source program and produces the object program for the respective source program. Now I am talking about if any programmer has made use macros in this source program. If a programmer had used the macros in this source program, then before the assembler can do or before the assembler can start doing its functionality of converting the source code to the object code, this before this assembly process, there must be something else. There must be something else which can take care about the macros which you might have used in the source program. That is the one which you call as macroprocessor. This macroprocessor, which is to process the macros which you made used in the source code. I already said I'm going to explain what is the necessity of macros, how to use it, all that I'll be explaining further. But as of now, just remember, if in a source program, if a programmer had made use of macros at the time of generating the program, and that scenario, in that scenario, before this program, which program, source program, before the source program is converted to the object program, before the source program is converted to the object program by making use of either you call it as assembler or compiler, before that conversion can start, there must be some processing should be carried out on the macros. There should be some processing should be carried out by the macros in available in the source program. That process will be taken care by the macro processor. So what is that process? What is that process? I'm saying that some process which is going to happen on the macros, but what is that process in the sense? It is nothing else than the expanding process, or called as expansion. So basically, what is the job of this macroprocessor in the sense? It is to just expand the macros whatever you use in the source code. It will expand the macros what you made use in the source code, so that it produces the expanded code, or in the you can also call it as expanded program. So this source program, or for this source program, before you generate the object program, who generates it is the assembler. Before the assembler can start generating the object program for the source program, this macro processing has to happen. What is the functionality of this macro processing? It is just an expansion of the macros what you used. It is just an expansion of macros what you just use. That is what the functionality of the macroprocessor. So here I just made used a few points here. So you can say that as macro. Why do we use in the sense? It is obviously the for the convenience of the programmer. It is for the convenience of the programmer we will be using. See, it is as same as if suppose in other programming languages also you might have use this as such a macros. So wherever, for suppose you might have used to fix the size of a queue, a size of the stack, or size of an array, wherein you might have used the macro definition. Or in the other way, let us think about, so where the programming code, a piece of the program functional code is defined, it is already defined, it is already stored, that you may call in your program, as a calling program. It's just a calling function. So that is also one of the type of a macro. So it is just a means of, you can say it as, it is for the convenience of the programmer. See, in what way I said as convenience of the programmer, in the sense the programmer need not to, I repeat, the programmer need not to write the same code for multiple times. If at all, if there is a necessity of repeating the same operation for multiple times, so obviously you should have the, if say for example I want to apply, just I'm taking an example of, I want to apply the addition of the two numbers for 5 times in my complete program. If I want to apply the addition of two numbers in for 5 times, in the sense, so I supposed to have the code which can perform the addition of the two numbers for 5 times. Instead of that, what you can do, what is other possibility, in a sense, let us define that in a separate macro. Let us define that in a separate macro, where that macro is called for 5 times with the 5 different kind of parameters. Say for example, it is first time it may be 10 plus 5, second time it is 5 plus 15, third time it may be 50 and 60, like that. What is getting changed, is only the parameters which you are going to pass as an input to that macro is getting changed, but what is going to happen in the macro is not changing. What is going to happen in the macro is not getting changed. So in that scenario, if you just take it as an example, so like that, for the convenience of the programmer, these macros, a programmer started using the macros. So again here the second sentence is very importantly, if you observe, it is the shorthand version of the complete program. In what way you say the shorthand version, in the sense, again let me take up the example of my own simple example. Like I said, 5 times in my original program, I want to perform the addition for 5 times. So instead of I have the same code for 5 number of times, instead of that you have it that only for once, and calling functions you will be having only calling functions for 5 times, which is you got as it's, whereas it is just like, you are not having the complete code for multiple times, you are having only as a one copy, as a programmer perspective. So it will be called for multiple times. That's what where it is restricted, the size of the program is reduced. So that is what you say it as shorthand version, I mean to say here. Whereas this is the third point which I want you to understand very importantly, which is the actual function of the macroprocessor. Because understand, again let me take up the example as, I'm just taking the example of again same thing. In my original program, I want to perform the addition of the two numbers for 5 times. So what I did, I use the same statements which can perform the addition for 5 times. Instead of repeating for 5 times, because every time the input is different. First time the input is 10 plus 5, second time the input is 5 plus 15, third time it is 50 and 60, like that. Every time when the input, just because input is getting changed, you don't have to have the code for multiple times, because operation is same. So what I'm going to do, in the sense, just I'm going to place that in a separate macro, and I'll be calling that macro for multiple times with the different parameters, So here,
So I think you have muted your mic.
no.
No, sir. No, we could actually hear you for like till 30 seconds before.
Can you tell me from where till where you, if that is the case, in the sense I
For last
didn't.
last 30 to
From the
45
third
seconds,
point.
we could not hear you.
Yeah.
Till the
From the
third
third
point.
point you didn't get it.
No, no.
Okay. First 2 points you heard.
Yes, sir. Yes.
Okay. That's okay. Do tell me whenever there are such kind of obstructions. Okay, let's take up the third point. So what I said in third point, as a part of your macroprocessor, so what it is going to happen in the sense, so yes, for the programmer perspective, it is just a 5 times you are calling the same macro, you are calling for 5 times. It's just for the programmer's perspective, it is just a 5 lines, whereas that is those 5 lines, just that's what every time you call that macro with the single line, in a sense that single line will not perform your action. I repeat, that single line will not perform the complete action. They're supposed to be the complete macro definition has to be fetched. It has to be put in your complete program or a original program. But who will do that? Who will do that? In the sense that is will be done by the, that will not be done by the assembler. Remember, that will not be done by the assembler, that will be done by the macroprocessor. So wherever there is a calling of the macro, wherever there is a calling of the macro, that in turn will fetch the complete definition of the macro definition. That's what macro definition will be fetched, and here it will be put. That's what you call as expanding. That is what the third point you can observe right here. That is the third point which you can observe. So it will replace each macro instruction with its source language statement. That's what it is going to expand all that. That's what I had written here at the term as expanding. It is going to expand each macro instruction which you just made using your program. That is what is going to happen in the macroprocessor. Then later, does the macroprocessor do anything else? In the sense, no. What I mean to say, does it know what is happening? In the sense, no. It doesn't even bother about what the functionality is about. That's what it doesn't bother about the meaning of the each statement. What is the functionality of the macroprocessor? If there is a macro statement, that's what I mean to say, macro calling statement. What you just fetch the macro definition of that statement and put it here. That's it, nothing else. It won't bother about what is going to perform in these statements. That's what I mean to say. It doesn't analyze the text, what it is going to handle, and very importantly, it does not bother about the meaning of those statements. What is the operation of these statements? It will not bother. It will just fetch those statements and put it in your main program. That is what the functionality of your macroprocessor. And finally, is it a machine dependent or a machine independent? In the sense, it is purely machine independent. It is not, macroprocessor will not be performing based on the different architectures in the different way. No, it is the functionality of the microprocessor remains same for any kind of machine architecture you take up. For example, in our example itself, whatever you studied as SIC and SIC-XC, if you remember, assembly process for SIC and SIC-XC is not same, right? So as assembly process for SIC and SIC-XC is different because architectures matters. Whereas for the macroprocessor, either it can be machine can be SIC or the machine SIC-XC, the process of microprocessor is remains same. That is what you called as machine independent. The microprocessor is purely machine independent. Now let us get into the very important functionalities of the microprocessor. So those are, I just named them as a macro definition, macro expansion, and macro invocation. So macro definition, macro expansion, macro invocation. So with respect to that, first let us take up the macro definition. So taking up the macro definition, remember, for dealing with the macros, can anybody just acknowledge me? Are you guys hearing? Anyone?
Yes, sir.
Yes, sir.
Yes, sir. We are.
And also PPTs are also visible, right? No
Yes,
disturbance.
yes.
If there is any disturbance, any one of you, just let me know in between also. No issue. And even if you have any queries also, you can let me know. Okay, let's continue. So here for defining the macros, however, you came across the different assembler directives for dealing with the macros. We do deal with the two assembler directives. Those are what? Macro and the macro end. So macro, which will give you the beginning of the macro definition, which will give you the beginning of macro definition, whereas macro end will give you the end of the macro definition. That's what M end. End. However, you came across with start will give you the starting of the program, end will give you the end of the program for the assembly, whereas this macro will give you the beginning of the macro definition, whereas end will give you the macro definition end or end of the macro definition. So like that, those are the two more assembly directive which you're supposed to know, which are to deal with the macros. Then so how do you say for example, if you're using any macros, if you're using any macros, in the sense every parameters which you make use with the macro definition, every parameter which you make use of in the macro definition, that must begin with the this and symbol. You said as ampersand, or you say that and symbol, and I think fine. So it must begin with this ampersand symbol or the and symbol. That's what the very important symbol, next thing which you're supposed to know. Now let us get into the actual part of the macro definition. Remember this in the macro definition, already I said what is the beginning? It is the macro assembly directive. What is end? It is the M end. So it should begin with the macro and end with the M end. It should begin with the macro, end with the M end, and in between there must be any instructions which to perform any specific operation. So that is what I call it as a body of the macro. This body of the macro, this is the body of the macro, which is nothing as set of instructions between the macro and M end, which defines the body of the macro to perform the specific operation. Whereas here you're supposed to know this macro, if I say that this is the macro which is going to perform specific operation, in the sense it must have the specific name. I call it as a unique name, which is unique name in any program, which is called as macro name. So for this macro, the left label part which is the macro name, whereas the right part will be the parameters on which this operation has to be performed. This operation has to be performed. If you take up the simple examples what I said, which is say for example addition of the numbers which I said in the beginning. But suppose for that this macro name will be something like add, and the parameter something like a comma b. However, in your C language you might have used something like add of a comma b, where add is the name of the function. Add is the name of the function, where a and the b are the parameters which you are going to pass to that function, right? In the same way, this macro should also have a name, because you talk about any programming language, there will not be any function without the name. There will not be any function without the name. So name is very important. That is what this is the name of the macro. Name is very, very important. Whereas you might have seen so many cases where there is a function without the parameters. Possible. You can have a functions without the parameters. So right here also the macro must and should have its own name, which is a unique name. Whereas these are the parameters. So this is where you will be passing the parameters, and every parameter should begin with what? Ampersand, or you say it as ampersand or and symbol. Whereas on these parameters itself, there you are going to perform something. That's what suppose addition example which I said, add of a comma b, inside which you may be performing as a plus b, right? So like that, this is where you'll be passing the parameters, and on that you'll be performing some kind of action which will be called as a body of the macro. So remember, this is the macro definition. You will be defining the macros like this, where the beginning will be given by the macro and the end will be given by the M end, wherein so that macro should have its own name and the respective set of parameters. Parameters can be any. So on those parameters will be performing the specific task. Then this is what this complete macro definition itself, you may also call it as a macro prototype. You may call this macro definition as the macro prototype. This is the macro definition. Again, let me go to the macro expansion. This is the simple example I want you to understand in detail. See here, if you observe, strg macro, inside that there are three statements. And this is where I am calling a M end. So this is what the macro definition which already done. This is the macro definition which is already done, wherein I am using this strg twice. This is just like a calling. This is just like a calling. I'm using this strg twice. It means to say that this strg stands for these statements, which is sta, stb, stx. Again strg, again stb. So this what I mean to say that in the sense, every calling macro. This is what I may call it as a. I'm just as of now. I'm just calling for your understanding. I call this as a macro calling instruction. But this is what you call as a macro instruction. Every macro instruction will be expanded based on the functional definition or the prototype definition. So every macro instruction, see, for this is for programmer perspective. Understand? This is for programmer perspective. It's just a matter of 2 lines, just 2 lines. Whereas for the assembler perspective, this 1 line is nothing as the 3 lines. This strg 1 line is nothing as the 3 lines. But who is doing this? Is what will be done by the macro process. It is expanding each macro instruction based on the macro definition. Each macro instruction is expanded based on the macro definition or the macro prototype. So that is what I call as expansion. This is for the programmer perspective, whereas this is for the assembler perspective. It has to take care like this. That's what I call it as macro expansion. But remember, this is what I said as macro prototype, and I didn't say what are these called as. So that is what the third part. I said here, as a basic macroprocessor functions, you must know about these 3, which I said: macro definition, expansion, and the third thing is very, very important. You call it as invocation. Invocation is same as the calling, because here I said this is the prototype building. This is what an example of prototype, which is nothing else than the definition. But if at all, if this has to be expanded, where it is going to be expanded, wherever you are calling, this macro, because this is the name of the macro. From this you can make it out. This is the name of the macro, which is strg. By using this name of the macro, if you call it, that is what you call as invocation. This is what invocation. Right here, this macro definition is invoked twice. You called it twice, 2 times. So that is the one of the means the third functionality you're supposed to know, which is the macro invocation. You may also call it as a calling. But does it? So but at the time of calling, what and all things you're supposed to know in the sense? Obviously, you're supposed to provide the macro name as usual and the parameters. Again, it is let me compare with the normal your C program itself. If there is something like add of a comma b, and there inside that there is a functional definition, how do you call that function? How did you call that function? You called with the same name itself. If the function name is add, you can't make use of some other name as sum. You must make use of the same name itself, right? So within that same name, and you'll be passing the parameters. So you'll be passing the parameters. Say for example, add of a comma b in the sense. Here you'll be passing as add of 10 comma 5 like that. You'll be passing the parameters, right? So wherein those parameters you may also call as arguments. You'll be passing the arguments to such parameters which are already used in the macro prototype. So that is what calling the macro. That's what I call it as macro calling instruction. Macro calling instruction should also have the exact name of the macro followed by the parameters, which are nothing else than the arguments. Now, this is what you call as macro calling. Here is one of my point is something like this macro calling itself we call as invocation. Is there a difference between your macro calling and the procedure calling? Because till now you might have come across with the different kind of procedures like subroutines. In a previous concepts, when you had studied about the assemblers and all, we came across with the subroutines. But you may get a doubt like, you may have a question like, is there a difference or same macro calling and the subroutine calling? Because if you remember, you can call the subroutine. You can also call, here we are talking about the macro calling. For the question like, does both are the same or different? In the sense, obviously different. Both are not same. Subroutine is different, macro is different. Remember, macro is different, subroutine is different. Even then, what makes the difference? I would say macro calling and the procedure calling, which is nothing else the subroutine calling. So what happens in that sense? If you call, I repeat this, if you call the subroutine, say for example, there is a functional code of belongs to the subroutine, and 3 times you are calling the same subroutine for 3 times. I repeat, you are calling the same subroutine for 3 times, but you whenever you call that subroutine for 3 times, you like now as a part of the assembler is going to consider it as a one copy itself, only one copy. Only the assembler need to generate the object code for only one copy for 3 times subroutine calling. Whereas for the macros, try to understand this is somewhat see, I'm trying to explain the different way. Try to understand. You may be calling the subroutine only, or sorry, you may be calling the subroutine for multiple times, but the assembler is going to consider the subroutine as a single copy. Why it is going to consider as single copy? In the sense, function to be performed in the subroutine remains the same, because you are not going to pass a different parameters. You are calling the subroutine for multiple times. You are not passing any parameter to that subroutine. You may be calling the subroutine for multiple times, so it is going to consider it as a single copy. Whereas with respect to our macros, macro definition may be same. Let again taking example of add. The functional definition of the macro is same, which is for the purpose of addition. But if you call the same function for 3 times, the parameters which you are passing may be same or different, but assembler will consider it as a 3 copies of the macro. Assembler needs a 3 copies for the 3 calling macros. Are you understanding this? Can anybody repeat, just acknowledge me, because this is very important. Can anybody acknowledge me? Hello, can you guys hear me?
Yes, sir.
Yeah, so
Sir, can you repeat, sir?
yeah, I will repeat, because I hope even I can understand you are not getting that, so I'll repeat. Just a minute, I'm just writing that. I'll repeat it. Okay, can you just acknowledge me? Is it visible? Is this visible? Can anyone tell me? Is it not visible?
No, sir.
Whatever I written on the book, is it not visible now? Can anybody? Is it visible or not? What I written in the book? No? Okay, no issue. Just a minute. I will type itself and show you. Yeah. Now my slides are visible, right? No issue with the problem. No problem with the slides, right?
No, sir.
No, sir.
It's visible. Yeah. So right now I'll just say that. So there is something like this, and here there are the so many statements belongs to the procedure, and then I'll be ending. So I understand this is what the procedure. I'm calling it this as a subroutine. This is what I mean to say. This is the subroutine, and here is my main method. This is what my main function, wherein I am calling that RDRAC for multiple times. I may be calling that RDRAC for multiple times. Try to understand this. I am calling this RDRAC. This is the RDRAC subroutine for my perspective. So even though you have the two calling methods, the same functional code, the functional code is not getting changed. It is for, even though you are calling this 2 times, but for assembler is going to consider this as a one copy, a single copy. It is going to consider as a single copy. Whereas you see the let me show the different case. As such, here instead of I call it as a procedure, here I'll consider as a macro. So this is what because by using this macro keyword, so if I use this, it will become macro. I'll say that a1, a2 are the two arguments, and here I'm going to do something and end with what? It is the m end, right? All of you are following? Now I'll call this rd followed by, I'll say 10 comma 5. Again there are a few more instruction. Again I'll call rd followed by 15 comma 20. Now if you observe right here, this is the macro definition, this is the subroutine definition, and this is what my main program. I hope you are getting this right now. See, from my main program I am calling the read record subroutine for 2 times, but your assembler is going to consider it as a single copy. It just, if the assembler could able to generate the object code for this only once, that is enough, because it is going to consider as a single copy. But from the main program itself, you are calling this macro, because this is the macro with the name as I am just giving a id. So from your main program, you are calling this id for twice, 2 times you are calling. As you are calling this for 2 times, so your assembler is going to consider it as a 2 copies, because you are bothering about here, you are bothering about the parameters. The parameters may change or not. In this example, if you observe here, now the parameters 10 and 5. The operation to be performed by this addition is different, whereas here the parameters are two parameters like 15 and 20. The operation to be performed by this macro is different, because the resultant is not same. For this the resultant is 15, for the second case the resultant is 35. So just because you will be passing the parameters like this, or you call as arguments, so assembler cannot, or assembler will not consider it as a single copy. If you call the macro for twice, so it will be 2 copies of the same code. If you call for 10 times, 10 copies of the same macro, it has to be expanded. There is a necessity of expanding same copy for multiple times with respect to the macro. Whereas with respect to the subroutine, you call for any number of times. That's what I call as procedure. You call for any number of times, it is just like, will be taking it as a single copy. I hope, did you understand this point?
Yes, sir.
So now let me go ahead. So that's what macro. Yeah, any queries? Okay, so that's what I called as macro invocation, and the major difference between the procedure calling and the macro calling. That's so very important, you're supposed to know. Now let me go to the next. Here I'll take up a simple example, and this is the simple example for string movement. I just written a simple program for string moving. So however, this we had in the introductory classes, something like moving the content of one string to the other string. So this is where I'm just taking one macro. This is the macro definition. If you understand clearly, this is the macro definition. What is the name of the macro? Because this is, here is the keyword like macro. This is the beginning of the macro, and label to this macro is the name of the macro, which is the move. Move is the name of the macro, whereas the right side, it is the parameters of this macro. How many parameters I have? I have 3 parameters. If you observe, it is what? Instruction, outstring, and string length. I either say that it's not instruction, in string. From which string you need to copy to which string? Because I'm copying, I'm moving the content of one string to the other string. From which string I want to move to which string I want to move, and what is the length of the string. So like that I'm making use of the 3 parameters. Remember, I'm making use of 3 parameters. Whereas if you remember, every parameter should be preceded with or started with the and symbol, or you said the ampersand symbol, which is very important. So inside this I'm just clearing the registers X and A, then I'm initializing X register, then string length is initialized to LDS. Then what I'm doing, I'm moving the content of in string to the accumulator. That again I'm pushing back, that's what storing back to the out string. This is the normal process which you already known. But what is different here in the sense, what I'm talking about till now, this is what is not this is the complete program, or the functional code is not the main program. This I had put inside the macro definition. This what beginning of the macro, and m end, this is the end of the macro. Wherein this macro I'm going to call in the main program. Remember, this is the main program. I repeat, this is the main program. In this main program, remember this is what LDT0, and this is the very important. I am calling the macro. By what? By the name of the program, by the name of the macro itself. I hope you remembered from the invocation I said. You will be having the name of the program, name of the macro followed by the parameters. So here move is the name of the macro. See, this is the move is the name of the macro which you just made use, followed by the three parameters, because you have the three arguments or three parameters with the macro definition. So you need to pass the three arguments, which is string 1, string 2, string 4. What it does? It is what moved from this string to this string. What is the length? So here you are passing string 1 as the input string, string 2 is the output string, from to where you need to move, and what is the length of that string. This is where you are calling the move again. Again, if you observe, we are calling the move again. We are calling the same macro move again with the different inputs, which is string 3 and string 4. I am moving the content of string 3 to the string 4 with where the size may be 10. Right? In this from this example, I want you to make it out that this is what you call as macro definition, or you may also call it as a macro prototype. Whereas this is what this is here, and these are called as what? Macro invocation. These are called as macro invocation. Yes. Yeah, so these are called as macro definition, and these are called as macro invocation, where you will be invoking or you will be calling those macros just by using the name of the macro followed by the arguments which you are going to pass, which is string 1, string 2, and so from which string. So if you observe right here, the string 1 is the part of in string, string 2 is the out string, and 4 is the length. The same is string 3, string 4, and 10. So I hope you are understanding. Now, when you pass this, when you give this as the input to the macroprocessor, because this program has the two parts. If you observe, this is the main program, and this is the macro definition. There is a macro. So when you give this as an input to the macroprocessor, what will be the output? I had given this in the different way. Try to understand. This is what the input program, and this is the output. Sorry, this is the input. What you are going to give. What you are going to give to the macroprocessor. So in that, this is the main program, and this is the macro definition. So from this, so what will be the output? So as usual, start. As there is a start command here, so write that start instruction. Then remember, as soon as you have the start, it will go to the main. That is what, which is the main? It is what? First LDT 0. This is the main. This is the beginning of the main function. This is the beginning of main function. Then next is what? You will be calling the move string 1, string 2, 4. So I hope you are reading this. You will be calling this move string 1, string 2, 4. But as soon as you call this move, the controller will jump to the macro and fetch the instructions from the macro. The complete instructions start from this clear X till this JT loop. You fetch whatever you have will be fetched. But all of you try to understand, this is very important point, such that see what was your macro definition has the three parameters or three arguments as in string, out string, and string length. Wherein here, if you observe LDS at the rate, LDS and symbol ampersand string length, LDCH in string, STCH out string. This is what the macro definition. But I repeat, but as soon as you call this macro definition from this instruction, at this instruction, as soon as you called this, from this instruction, can you observe this? Can you observe this? This string 1 will be the parameter, this parameter to this in string. So wherever you are using in string inside your macro definition will be replaced as string 1. Wherever you are using this in string will be replaced with the string 1, because this string 1 is the parameter to this in string. In the same way, string 2 will be the parameter or argument to the out string. So wherever you are using out string, will be replaced as string 2. Again, 4 is the parameter to the string length. So wherever you are using string length, that will be replaced as 4. That's what this is the value of the string length. So like that, as soon as you call this, what has happened? It has just expanded this one line with so many lines. That's what expansion is done. At the same time, parameters are replaced with these arguments. whatever the parameters you made use, which are replaced with these arguments in the same order. It is in the same order, not in a different order or not in a random order, because string 1 is the value for the in string, string 2 is the value for the out string, 4 is the value for the string length. So they are replaced in the same order, right? So what we did this. Next, what is the next instruction? It is what? RMOTA. Same thing again. What is the next instruction? It is the add hash t. What is the next instruction? It is the RMOAT. What is the next instruction? You are calling again the macro. Now you are calling the macro with the different arguments. Earlier you called with the string 1, string 2, 4. Now it is string 3, string 4, 10. Now you can guess again. As soon as you call this move with these parameters or these arguments, it will get the complete thing. But this in string will be replaced with the string 3. So this will be replaced as string 3. Whereas out string will be replaced as string 4. String length will be replaced as 10. That is what has happened if you observe. So string length is replaced as 10, in string is replaced as string 3, and out string is replaced as string 4. After this, what is the last instruction? Obviously end, right? So from this again, I would like to make it one more point. Whatever we discussed in the previous slide, as based on the number of times you call the macro, those many copies you need to consider. The assembler is going to consider those many copies, or the macroprocessor has to expand those many times. That's what I said. Because if you observe right here, if you the assembler or the macroprocessor could be considered this as a single copy, it cannot perform. Because see, at this case string length is 4, at this case string length is 10, at this case in string is string 1, whereas at this case in string is string 3. Like that, based on the arguments you pass, macro definition is getting changed, expansion is getting changed. See, the macro definition is maybe same here, but based on the parameters or arguments you pass, definition is getting changed. Any number of times you call, those many copies you need to generate. That is what you call as very important functionality of the macroprocessor. So take the macro calling instruction and take the parameters and go to the respective macro prototype and replace each and every, very importantly, replace each and every argument with the parameter in the respective place wherever you are using inside the program. This is the, see, and try to remember. So previous slide, whatever I had given, that was the input to the macroprocessor, where it had one macro definition with main program, whereas output from the macroprocessor is this. So this is the input to the macroprocessor, where it has a main program and the macro definition, whereas this is the output from the macroprocessor, which is expanded code. Expansion is happened based on what? Expansion happened based on the macro instruction. This is what one of the macro instruction. This is the second macro instruction. Based on the macro instruction, the code is expanded. That is what I used to say again and again. The output from the macroprocessor is the expanded code, whereas the input to the macroprocessor is the source code with the macros. Simple source code with the macros. Output is expanded code. This is the one which is going to be given as input to the assembler to generate the object code for each and every instruction. Now you see, this is what even one of the statement we saw in the first line, as it is the shorthand notation for the programmer. This is what if you observe, this is the size of, you see the size of the code. Whereas what about this? This is the expanded one. For the user perspective, this is shorthand. Whereas for the assembler perspective, it has to be expanded. Who does that? It is not done by the user. It is done by the macroprocessor. So burden to the programmer is nothing. Because it is taken care by the macroprocessor. So that is the major functionality of the macroprocessor. So I'll be explaining about the with the further which is somewhat a bigger program example. Before that, did you understand this simple example, the functionality of the macroprocessor? Guys, anybody, can you respond?
Yes, sir.
Any doubts? Anybody? Any doubts till now?
No, sir.
Okay, then let us take up the next example. So here is the example where I'll be considering the two macros. Earlier I just considered one macro. So here I'm going to consider the two macros. One macro is here, you can observe. This is what the macro. So whereas the name of the macro is read buffer, where there are the three parameters, which is indiv, buffer address, and this is what the record length. So like that, there are the three parameters to this macro. So there's the read buffer, macro, and these are the three parameters. So, and this is where there is something which is happening inside this. So this is again the same thing whatever we had discussed in the previous examples. So again, let me not elaborate this again. So this is the beginning of this macro, and here is the end of this macro. This is what one macro definition, whereas the name of that macro definition is read buff, RD buff. I'll take up one more macro definition. So here this is the one more macro definition. See, you can again see this one more macro and end. So what is the name of it? It is the write buffer. I call it as a write buffer. Again, this also has the same different, but three parameters like out, buffer address, and the record length. Like that. So I'm considering the two macros. This is the one macro is this read buffer, and the second macro is write buffer. Like that, I'm considering the two macros in this example. Now let me go to the main program. This is the main program. This is the main program. From this, if you just would able to understand clearly, this is where I am calling the one of the macro as read buffer, whereas I am passing the three parameters, which is f1, buffer, and the length. I'm passing the three parameters, which is f1, buffer, and the length. Again, I'm doing something inside it. Again, here I'm calling the one more macro, which is write buffer with the 0.5 buffer and the length. Again, I'm doing something else here. Again, I'm calling the write buffer with this, with the 0.5 UOF and the 3. This is in this main program. If you could able to notice, I am calling the macros for 3 times. I am calling the macros for 3 times. One is here, second is here, third is here. But I am calling the read buffer only once. I'm calling the read buffer only once. I'm calling the write buffer twice. I'm calling the write buffer twice with the different parameters. You can observe here the parameters is 0.5 buffer length. Here the parameters is 5 UOF 3. Like that, I am calling the same macro here, which is write buffer for twice. I'm calling the read buffer once. So from this main record or this main function or main program, I'm calling the 3 macros. I'm calling the 3 macros. Which are those? It is what? This write buffer is twice I called, and write buffer I called once. So this is the complete program which is generated by the programmer. Has the 3 parts in it. One is write buffer macro. One is the read buffer macro, write buffer macro, and it has a main program. This is given as an input to your macroprocessor. As soon as you give this to the input as a macroprocessor, this is what you generated till now. I just take an example, current example. In the current example, I had the 3 parts. The source code has the 3 parts. What are those 3 parts? In that 2 macros we had. One is read buffer, write buffer, and third part of the program is simple main program. That you are giving as input to the macroprocessor. What should be the output from the macroprocessor? It is the expanded code. Now, if you could able to analyze how many expansions required in the sense, it is 3 expansions required. For which are all the 3 expansions? One is for read buffer expansion, and write buffer expansion need to be done for twice for different inputs. Remember, different parameters, because when for this write buffer expansion the parameters is 0.5 buffer length, whereas for this it is 0.5 UOF and 3. Like that, parameters are getting changed, arguments are changed like that. So when you gave that as an input to the macroprocessor, the expanded code will be produced as an output from the macroprocessor. Whereas how many expansion is the totally 3 expansions. One is for the read buffer and the 2 for the write buffers with the different arguments. That is what is going to happen. Now let me show that as well. So if you remember, this is what the macro definition from my previous slide. This is what the macro definition, and this is what your main program. From the main program, see, try to understand this. From the main program, so what you had, which is first STL return address. As soon as you have first STL return address, you have what? You are calling the macro. You are calling the macro with the label as cloop. If you observe, you are calling the macro. Which macro? It is the read buffer with the 3 parameters as what? F1, buffer, and the length. These 3 arguments which will be considered as an input to this. So F1 will be the indiv, whereas buffer will be the buffer address, whereas length will be the this record length. So these 3 arguments will be considered as these 3 parameters. So wherever you're using these, just replace. So you can observe wherever you're using indiv. So this is where you're using indiv. Replace with what? This F1. You are going to replace with this with the F1. Again, where are you using this? Again, you are using indiv. Again, you can observe RD indiv. So you replace this indiv with the F1. So you will be replacing that with the F1 as well. Again, where are you making use of this buffer address? Wherever you are using buffer address, this is where you are using buffer address. That should be replaced what? Second argument. It is the buffer. So replace with the buffer address. Last, where are you using this this record length? You are using record length here. Replace that with the length. So like that, just one line. Which line? This one line of code for this is only one line of code for the programmer perspective, whereas this has to be expanded. That has to be expanded to these many lines for the assembler perspective, which will be done by the microprocessor. So again, it is not only expanding, it is also replacing the respective arguments with the respective parameter location, whatever it defined in the macro definition. So what here you can also observe and try to understand in the other way. So you can observe this C loop read buffer F1 buffer length. What is the line number of this? It is 190. What is the next line? It is the LDL length. It is at the line number 195. So from this is the line which has to be expanded. That expanded thing, can you see this line number also differentiated? That's for your understanding. It is not the further these lines. See what we are trying to prove here in the sense. Just because this line has to be expanded, further lines are not overridden. It is not that because you want to expand this one line to the 10 lines, further 10 lines are not overridden, or it is not overwritten. You're not going to override on it. You are expanding this, keeping the other instruction not disturbed. You should not disturb the other instructions as well. So only the line number of LDA length will be retained as 95 itself. If you observe, LDA length as 95, compare 0 as 200, this will be written same. Whereas only this 190 instruction is expanded. That is what, in order to tell you guys in the different way only, the line numbers are 190, 190, A, B, C, D, E. You can observe this. So what you're supposed to understand from this in the sense, it is not the A, B, C, D is. You're supposed to understand that just because you are expanding this line, that is not going to override the further lines, right? Those lines will be retained in the same location. Like LDA length, compare 0, Jake, those will be retained in the same location. Only you are expanding that to be based on the macro definition. So this is what we've done with this. Again, let's go to this write buffer 05 buffer length. So if you take up this again, as usual, you need to expand this write buffer with the 3 parameters as 05 buffer and the length like this. You are going to expand this. You are going to expand this as, so now 05 will be the argument to the outdiv. Buffer will be the argument to the buffer address, and length will be the argument to the record length. So wherever you're using them, you just replace with them. However, see, this is where you are using record length, so replace with the length. Again, here you are using buffer address here, replace with the buffer. Here you are using the outdiv. These two cases you are using outdiv. What is the argument to that outdiv? It is the just a 05. Just replace it. So this is what an example of this write buffer. Again, let me take up this write buffer where now you see the parameters are different. It is 05 UOF and 3. It is 05 UOF and the 3. Now when you pass that, it is 05 UOF and 3. So 05 will be the parameter to the outdiv. UOF is the parameter for the parameter buffer address, and 3 is the parameter to the record length, not record length. So those has to be replaced as usual. And once after this is done, further instructions are not changed. Further instructions unchanged till the end instruction. So where did you start? From the start instruction. Wherever you are using, wherever you are calling that, wherever there is a calling function or calling instruction to the macro, that is what I call it as a macro invocation. That macro invocation instruction has to be expanded based on the macro definition. Based on the macro definition, that has to be expanded. So as in this example, 3 expansions will happen. So finally producing this program is going to change as this complete program. This is the output from the macroprocessor. Start from the start instruction till the end, wherever you had. If you remember, this complete thing for the programmer perspective, this complete thing was a simple instruction as a read buffer, whereas this is completely instruction as a write buffer. Again, for this also there was single instruction. So like that, those three instructions are expanded to these many instructions based on the macro definition. And who did it? There's the macro processor. All of you are following this? Anybody has a query? Yeah guys, anybody has a query, you can ask me.
Sir, in write buffer, when we are sending the parameters 0, 5, EOF and 3, why we are not using hash symbol, sir, for 5?
Yeah. See, you're not 05 is not the decimal number; it is the hexadecimal number. So if you remember, the output device number I said that as 05 and input device number as F1. That 05 I mean to say here, it is, these are not the decimal numbers. It is not, you are not, if you make use of hash 5, it will be a decimal number, whereas these are the ASCII value, hexadecimal number of the output device number. So only you should not use as a hash here. If you just make use of hash, it will become a simple decimal number. But here the 05s, however, you are using F1, which is a hexadecimal number, ASCII of your input. In the same way, 05 is the hexadecimal ASCII of your output device. So only there is no, you should suppose not to use the hash. Any queries? Is it clear before that?
Yes, sir.
Any queries? So if there are no queries, now let me just put all the things together. So now what is the changes you observed from the input to the output? That's what. So from when you think about the input to the output, what I mean to say, when you pass these as an input, what is the output you are getting? So very first difference you supposed to know is that macro instruction definitions have been deleted. What I mean to say, see. Yeah, this is where I told you that as soon as you have this write buffer 05 UOF3, that will be expanded based on the macro definition. But we did not make use of these two instructions, which is wherever you have this macro instruction and amend instruction. We did not replace this. If you remember, only we fetched this definition part, that is from after macro, that is from clear X till before this amend. That's what till this JLT. This actual instructions which will not be used, because the definition is only this, so you don't have to make use of this heading, this header part. So only that is not used. That's what those are deleted. Next, macro invocation statement is expanded. That's what I mean to say. So here this is the macro invocation statement. This is a write buffer with the parameter. This is the macro invocation. You are inviting, you are calling. That is expanded to the multiple instruction, which is without disturbing the other instruction. So if you see, the line number of this is 220, line number of the next instruction is 25, 30 remains same. You are only expanding this without disturbing the other instructions. And also third point is that you are going to replace wherever you are having out buffer record length, you are going to replace with the 05 UOF and 3 in your definition. That is already I said in the just few minutes back. And the last point, which I want you to observe, which I hope you might have observed already. So like this, what are these JEQ star -3, JLT -14? It's supposed to be something like, however we used in the previous examples, like jump if equal to somewhere, right? Jump if less than to 14. Here jump if less than to 14, jump if equal to 3, again jump if equal to 3, it is jump if equal to plus 11. You can observe this again. It is not -11, it is a plus 11. Again JLT -19. What are these numbers? 3, 11, 19. That is the last point which I want to highlight here. Again, we are going to take up this as a generic identifiers, generic label identifiers, where we have a separate concept. There again, we are going to deal this global identifiers. But as of now, let me only just tell you in a simple means. Just in a simple means, I'll just tell you in one or 2 minutes. As such that, so why do we use these numbers? In the sense, these are called as identifiers. These are called as identifiers. Why do we use these identifiers? In the sense, instead of these identifiers, if you make use of labels, what I mean to say, see, in your program, in your main program, you may be having the 3 times, you may be invoking the each You may be invoking each control section, sorry, macros. Whereas inside macro, you have this JEQ star -3, which is as same as, this is as same as jump if equal to this 3. But in a programmer perspective, it is where jump, it is what? Jump if till the input device is ready. It will be, you will be keep on jumping. However, we had in our input programs something like jump if equal to JQ R loop. Jump if, because previous instruction is what? TD, test the input device. I hope you remembered. You'll be testing the input device until unless that input device number, the control flag, if it is equal or less than. If it is equal, you will be keep testing until it becomes less than. So this jump if equal -3 is nothing else. You will be jumping back to this instruction itself, and you'll be keep continuing this until the device is ready. That's what -3. Why this minus? In the sense, it is what? Backward referencing. It is what? Backward referencing. Whereas 3 in the sense, it is with respect to the memory that we are going to see further. I'll tell you about the why 3, 11 and 19 and all. They're separate concept. Again, but minus is for backward referencing. Whereas here, jump if equal exit. Where is exit? This is where it will be. So which is where you'll be forward referencing. You'll be go for jump into the further instruction, which is what? This is what? Plus. Again you have minus, which is again it is what? JLT loop. That loop is somewhere here. Again it is a backward referencing. That is the final point which I'll just highlight here, but I want to explain that in detail in the further classes about this, why these numbers are used instead of the labels. So that is what again I'm going to explain further. I hope those are the major differences you observed from the input to the microprocessor and output from the macroprocessor. Yeah guys, any doubts till now? Guys, any doubts? Whatever I had explained today? Any messages? Yeah, you can also ping me through the conversation box as well if you have any doubts. Yeah guys, can you hear me? Any doubts? If there are no doubts, at least say no with respect to the message, or you can say no if there are no doubts. If you have any doubts, you need to ask me right now. Yeah. Okay, if there are no doubts in the sense, this is the end of the today's session. Tomorrow I'll be taking up the next topic as the whatever we discussed till now. With respect to that, let's generate the algorithms and let us also deal with the data structures, whatever the data structures used by the macroprocessors. So that will deal tomorrow in the next session. Okay. If there are no doubts, I'll stop the today's class.